Okay, so two long plates of glass, n equals 1.4, are arranged with human hair holding the ends apart to the surface of the plate. Okay, wavelength equals 700 nanometers. This makes the bands of interference parallel to the ends of the arrangement, which are also called fringes. Okay, is there a light fringe or dark fringe where the two ends touch? Okay, so basically, like, if you're gonna draw a picture of this thing, so he's saying you have like one sheet of glass and like another sheet of glass, right?
Yeah. And they're like separated by hair or something.
Yes, and there's like a hair in here. Or whatever.
Is it supposed to be like a little angle, or is it supposed to be like basically parallel?
I think it's supposed to be an angle, because it says, is there a light fringe or dark fringe where the two ends touch each other?
Oh, okay.
So that's like where the two ends of the glass touch.
Gotcha.
So that's usually what you see like when you look at,
Okay.
like, yeah, these sort of like thin films. So the end for this glass is 1.4.
Perfect.
So, this is like a side view. So if you were to look at like a top view of like the two plates, it's saying like you have like a dark spot on one side, like a light spot, dark spot, light, well, like that, dark. And then on one side there's like a light spot. So one end there's a dark spot, and then like one there's a light spot. So it's saying, is there a light fringe or dark fringe? So these are fringes where they touch? Yeah. And there's going to be a dark fringe.
How do you know?
So that's just something that like, when you deal with this like sort of thin film, that's just something that it is. Like, for instance, it like talks about it in the book.
It's just because they're touching. It's just like a given, just something you just have to memorize kind of thing.
Yeah, I think it has to do with like the phases too. Like, so I think when it hits, this is like out of phase, which means that like, so you have basically like, how do I describe this? So you have like a light that comes in like this, like a light wave, right? And it hits.
Yeah.
So if it hits a certain medium, if it's if it's in phase, it'll bounce off into the same phase. If it's out of phase, then it'll be the opposite. It'll go off sort of like that.
Oh, okay.
So this is in phase, and this will appear like bright.
Okay.
And this will appear dark. This is out of phase.
So it's out of phase.
Yeah. And this is, let me double check, but.
So I could say the light would diffract back out of phase? Is that what it is?
Yeah.
Or is it where it hits? Because it's not like this that matters, right? Well,
Yeah.
I mean, is this and this basically the same? It's just this is the different part?
Yeah, so this is like it coming in, and then this is like the second part, and it bounces off. This is the same light wave. Yeah, so, let me play with. Yeah, like this. So like it comes in and then it hits. So this is like out of phase.
Okay.
So this is if this happens. So this is N1. This is N2. So this is the medium, and then it hits this medium.
Mm-hmm.
And like some, it'll keep going too, like through the medium, but some bounces off. So if N2 is greater than N1, then it's in phase. So for instance, if N1 is equal to 1 and this is 1.5,
yeah,
it's going to bounce off and it's going to be in phase.
Okay.
So if N1 is less than N2, oh, that's what I just did.
Yeah. So
If it's greater, so if N1 is like 1.5 and N2 is 1, then it's going to be out of phase and it'll switch its position. So if it's coming in like this with a peak up here, it's going to bounce off with its peak like that sort of thing.
Okay. How do we know? How do we know the ends, other than it's just given, it just says it's
Just 1.5?
1.4.
Or, yeah, 1.4.
So like, how do you know that in 1 is greater than in 2? Like, if
Oh,
it's
for
given-
this case?
Yeah,
Um,
kind of don't.
yeah, see, I don't really know, like, I don't think it matters so much for the end part because, let's see. So this, like, part talks about it a little bit. Let's see if I can. Oh no, that's not. So here we have, like, a similar idea, right?
Yeah, there you go.
So let's see. Let me see. Lower surface where the beam strikes air in the glass, blah, blah, blah. Okay, so thus the two rays reflected at the point of contact A on the two glasses where the gap is approaching zero thickness will be half cycle out of phase and a dark spot occurs. So like when it hits here,
Out of phase, dark spot.
yeah, so it's gonna be out of phase and a dark spot.
Okay, I'll just go with that.
Yeah. So it's just one of those things, like, I don't really, so much for these, I don't really think it matters so much what the N is for glass.
Okay.
For other situations, like,
With
this
the-
is good to know.
With the
But-
light ray coming out would be out of phase. Is that correct?
Yep, yeah, exactly. Yeah, the light rays that reflects back is out of phase. So it's gonna, when you're looking at it, so you're like this person that's kind of visualizing it. If when you see it, it looks dark.
Perfect.
So the dark, yeah, so this dark side right here corresponds to that end.
Yeah, that helps. That makes sense.
Yeah. It's a little weird, but like, yeah, you'll get used to it as, you know.